Now that we have developed and built our first SharePoint framework web part, let's take a little bit of a step back and just make sure we're all on the same page in terms of the core technology that is underneath the hood in SharePoint Framework Solutions. In particular, I want to make sure that we're all very comfortable with the TypeScript language. And if you've never used TypeScript, you can read all about it at typescriptlang.org. It was originally developed by Microsoft, and it's defined as a superset of JavaScript. And basically what that means is TypeScript is JavaScript, but there's some extra stuff on top that you can choose to utilize in your TypeScript files. And when you have a TypeScript file, it can compile down to normal plain old JavaScript. So the process generally goes, you write TypeScript and then you have some sort of build process that takes that TypeScript file and turns it into a JavaScript file, which can then be read by the browser. So let's get started by switching over to our terminal, and we are going to need a couple of npm dependencies before we can start building things in TypeScript, and that's going to be installed using the npm install command, and globally we're going to install both TypeScript as well as tslint. With those installed, we're going to open up a solution called TypeScript Crash Course. If you'd like to follow along, you can download the starter solution from the link in the description down below this video. And if we open this folder up in Visual Studio Code, you will see it's a quite simple structure. We have a couple of TypeScript config files that you really don't need to worry about. They just need to be there in order to properly compile the files we're going to be writing, as well as a source folder, which has an index.ts file. And if we open that up, this is our application that we're going to be working in as we're testing out some TypeScript features. This is a pretty simple application. We have a cart, a shopping cart of products, if you will. We have a method called add, which allows us to add a product to the cart using a name, a price, and a quantity. We also have a total method down here that's going to calculate the cart's total using each product's price times its quantity, and it's going to return that. And finally, at the bottom, we're using these methods. You can see add products to cart. We're adding some apples and oranges, as well as calculating the total of our cart at the very bottom. So all in all, pretty simple. We're not actually going to run this in the browser. We're not going to render a UI or anything. This is all just to demonstrate the features of TypeScript. And in order to do that, we are going to have to jump back into the terminal and run the TypeScript compiler, or TSC. And the way you use this command is you give it an input or an entry file. So in this case, we want to go to source/index.ts. You can optionally set an output directory. Otherwise, it's going to output the JavaScript file that's compiled to the same directory. So I want to set an out directory of dist. So we're going to push all of our compiled files to this distribution folder. And then finally, I want to run this in watch mode because I want it to automatically update every time we make changes to index.ts. Let's go ahead and run this command. It's going to say starting compilation in watch mode. Let's switch back into Visual Studio Code, and you'll notice that we now have a dist folder, and within that we have index.js. And I'm actually going to go ahead and open this in its own panel so we can look at these side by side and see how they differ. And right off the bat, you will notice that there's actually very few differences between the TypeScript file on the left and the compiled file on the right. Other than a little bit of white space being removed from the compiled file, it is identical to the TypeScript file you see on the left. The reason being is because our TypeScript file is just plain old JavaScript. So when it goes through that compilation process in the TSC compiler, it is not actually being changed, because the goal of that compilation is to take your TypeScripty things and to compile those down into something that is going to be more browser friendly, something you can actually execute in the context of a web browser or an application that you're writing. So in order to demonstrate some of the differences, the first thing I always like to point out when I'm teaching TypeScript is the fact that in your TypeScript files, you can use a lot of the same ES6 or ECMAScript features that you're used to using in modern JavaScript. For example, we could take our cart, and instead of using a var keyword to declare that, we could change that to const. And likewise, in the three areas where we're setting up a variable, so we have our var sum equals 0 and our var I equals 0 inside of this total method. So let's change those. we can change those both to let. And similarly down here in the bottom, when we're getting our cart total, let's change that to a const as well. And when we save this, you will actually notice on the right, you don't see any changes. And that's because the compiler knows that the ES6 that we're writing on the left is not quite as browser friendly as just pure JavaScript variable declarations. And therefore, it's going to compile those const and those lets down to just a simple var declaration. We can continue to add ES6 to our total method just to see how that differs and how that compiles down. And for example, normally when you would want to loop over an array, you could certainly always use a for loop, but a little bit of a cleaner perhaps syntax would be using an array map. So for example, we could say cart.map, and then we could take each product in the cart and use an arrow function to return sum plus equals product.price times product.quantity. And then we could get rid of this for loop. And as we save, you'll see that update on our compiled file on the right. And it's almost identical in this case, but you actually notice that our arrow function, so when we're saying cart.map product, and we're using this arrow function to return this expression, it's actually compiling that down to just a normal function over on the right. And again, it's just trying to make that be a little bit more browser friendly. So when it's actually executing in the context of a web application, you'll have fewer issues with that syntax not being supported. Another thing we could try is using the destructuring syntax within ES6. So for example, up here, when we're pushing an item to our cart array, we're actually saying name is equal to name, which is the parameter of our method up here. Price is equal to price, and quantity equals quantity. So in this case, we could actually take each of these, and using the destructuring, we could just simply say name, and I'll just replace all of these real quick, name, price, quantity, just like that. And that's the exact same thing. And as you'll see up here in the compiled version, it's not actually using destructuring. It is still setting name colon name, price colon price, quantity colon quantity. And that's kind of one of the key aspects about TypeScript that you should start to realize is that TypeScript is all about developer confidence and the developer experience. It really has nothing to do with the runtime, the application that's actually running in the browser that your users are going to interact with. TypeScript is all about improving the developer's workflow and making developers more confident that they know what properties are available on what objects and what methods, and that it's enforcing this idea of developer confidence that you're going to see throughout a more complex application. So ES6 is great. You guys are probably happy that you can start utilizing that in your TypeScript file, but we're still not doing anything quote unquote TypeScripty in our TypeScript file. And as its name implies, the biggest element of TypeScript that you're going to want to start to identify is types. In a lot of other programming languages, you have this idea of strong typing, where when you declare a variable, you have to declare it as a type. So for example, once you declare a variable as a string, it will always be a string, and it can't really be converted into any other type. And that creates a sense of developer confidence, because then that developer knows the string is not going to be inadvertently converted to a Boolean or to a number. And then that's going to start to throw errors in your application. And especially when you have a large team of developers working on many different pieces of code and you start passing things back and forth, not having types can become tricky very, very quickly. And JavaScript traditionally does not have types. You can declare a variable in JavaScript as a string, and then you can change it to false on the very next line, and there's really no consequences to that. It's really up to the developer to make sure that types are predictable. And the traditional ways of doing this in pure JavaScript are through good documentation to ensure that developers know what types and what argument types are being expected so that things don't become inadvertently changed, or through testing. Just making sure that your application works by testing it in the browser. Really, one of the main goals of TypeScript is to avoid that requirement of, number one, writing really detailed documentation and relying on developers to write that documentation. And number two, avoiding the whole in-browser testing process as much as possible. That's not going to go away. You're still obviously going to need to test your application, But the whole idea of TypeScript is you can catch a lot of the errors you may have otherwise identified in the browser before you even get there, which is going to save you a ton of time. For example, let's say that you have a developer on your team who comes into this file and they say, okay, we need to add a new element to our shopping cart. Let's go down here and we're going to add 3 bananas at 99 cents a pound to the cart. As you can see, there's no indication that there's an error here. However, in this case, our arguments are in the incorrect order, and we would not actually be able to identify that as a bug or as an issue until we would start to observe that during the testing, during actual browser testing, where we can see this is either throwing an error at runtime in the browser or it's causing some unexpected behavior in our application and break something else. And that's not ideal. It's much better to be able to catch this sort of issue early on before you even get to the browser, because that's going to save you a lot of time. And that's where types come in TypeScript. So now, for example, if I come up here to our add method and I'm going to add a type to this method parameter name, and I'm going to say we are expecting a name of type string. And you do that simply by adding colon and then adding a type here. So in this case, we're going to add string, and now you'll notice as soon as we do that, down in our add method, it's actually giving us a little red squiggly. It's saying, wait a second, argument of type 3 is not assignable to parameter of type string. And realizing the error of our ways, we can now fix our method to make sure that our bananas are properly added to the cart. We can also type our other method parameters, which is probably a good idea. So on both price and quantity, let's make sure they are of type number to ensure that if for some reason somebody wanted to add some chicken and pass in the price as $5.99 a pound at 2 pounds, it's going to yell at them and say, wait a second, IntelliSense is not happy. The linter is suggesting that you pass in a number here. So now suddenly it becomes very difficult for the developer to not know what's going on, because we're starting to use types and we're starting to enforce that developer experience and that idea of high confidence development. Not only that, but take a look at this IntelliSense. When we just type in add, you can see name is string, price is number, quantity is number, and the return type is void. So suddenly by utilizing these TypeScript types, you're going to start to get some really nice IntelliSense, and we're going to continue to see that, especially as we add some of the other features of TypeScript to our application. So I'm going to save this so we can check out what this looks like over in the compiled version on the right. And you will notice, first of all, that the types are missing in the compiled version. And again, there's no idea of types in pure JavaScript. So as this goes through the TypeScript compiler, on your add method, it is merely showing us name, price, and quantity, just like it was before. And while the developer experience is pretty rigid at this point, and we are making sure that every time we as developers call the add method, we're passing in the right types of parameters, this is not some sort of validation that's running in the context of your runtime within your web application itself. You are still responsible for making sure that whenever you capture user input, that they are actually providing strings or numbers or what have you. Another thing you can do in TypeScript is provide types as return types of your methods. So for example, our add method doesn't return anything, and we could specify a return type of void. Similarly, on our function total, this is actually returning a sum, which is a variable of type number. So in this case, we could continue to add types by saying sum is a number, and then the total method actually returns a number. And once you start doing this with your method return types, you'll actually notice that in your IntelliSense, and as you use this in other areas of your application, so for example, down here where we're calculating our cart total, if you hover over the total method, you can see it returns a variable of type number. And not only that, but the cart total itself, it inherently knows that that is of type number because we are assigning it to the return value of our total method. So this starts to permeate a lot of different areas of your application as you start to utilize TypeScript types, and you're going to see a lot of benefits, especially in more complex applications as opposed to the really simple application that we're building now. So let's say that we want to add a new property to our product object. And let's just say, for example, that we perhaps want to track whether or not a product is on sale. So we can add a new parameter to this method that is called on sale, and that's going to be of type Boolean. It's going to be either true or false. Now, as soon as we add this, all of our add methods are going to start to yell at us. They're going to start to give us an error because we now have a required parameter in the add method that is not being passed in. So you'll see each one of these is going to say expected 4 arguments but got 3, an argument for on sale was not provided. If you would like to utilize an optional parameter, and you don't want to have to specify that, you can just add a question mark before the colon. In this case, on sale is now an optional parameter, and now all of those errors disappear because we don't necessarily have to provide whether or not it's on sale. And then now in our add method, we can add on sale to our destructured object that is being added to the cart. And that's either going to be added as undefined whenever this is not passed, which is fine because that's still a falsy value for doing true false checks, or it's going to be added as true or false if that's actually passed in up at the top. And now what you'll see is down here, if we decide our chicken is on sale, we can just say comma true. And you'll see in the IntelliSense there, it's actually listing on sale with that question mark colon, indicating that it is an optional value. You can even add a default value. In that case, you're not going to mark it as optional because when you have a default value, it's always going to be set, so it's not optional. But what you can do is say on sale is of type Boolean equals false by default. So if somebody doesn't pass that, it's just going to set on sale to false, which is probably a better use case in this particular example. And as we save this, you will start to see a little bit of a difference in our compiled version because we are using a default value in the compiled version of our JavaScript over on the right. We now have our on sale parameter, but then the TypeScript compiler adds if on sale is equal to void, then on sale is equal to false. So it's starting to do a little bit of that compilation magic where it's taking our nice, simple ES6 or ECMAScript TypeScript stuff that's on the left, and it's compiling it down to more friendly JavaScript over on the right. So let's add one more parameter to our add method to demonstrate how we can work with array types in TypeScript. And just as an example, we can say that in addition to our name, price, quantity, and whether or not a product is on sale, perhaps we also want to capture an array of discounts available on that particular product. So let's add a discounts parameter of type string array. And you can specify the type as an array by using those square brackets, just like you see here. And let's give that a default value of an empty array. So if you don't provide it, it just won't have any discounts. And we'll also have to pass that into our cart itself. So we'll add discounts to our object that we're pushing to the cart array. And then now down here, when we're adding our chicken, let's also specify some discounts available, such as 20% off. And we also have a coupon. So at this point, we are working with strings, numbers, booleans, as well as arrays, which are sufficient to be able to describe a large amount of data, variables, and parameters in any web application. And that's great. However, there are often many instances where this is not sufficient to describe more complex data that may be present in any web application. And let's take the example of our shopping cart in this case. We know that it's an array because we're defining it as an array at the very top of our file. However, that array actually consists of objects because every time we're adding a product to the cart, we're actually adding an object with properties such as name, price, quantity, etc. So if we wanted to actually type this variable and describe to the TypeScript compiler what it consists of, you may think, well, this is an array of objects. But that actually won't work because you'll see in our total method, once we do that, it's actually saying, hey, wait a second, product is an object and price doesn't exist on type object. And that's because object is not specific enough. Object is just any old object in JavaScript, and it doesn't necessarily have any properties. So to fix this, we're going to use what's called a TypeScript interface. At the very top of our file, let's create a couple lines here, and you can create an interface simply by typing interface. And in this case, we want to create an interface for products. An interface is basically just describing what an object looks like in your TypeScript application. So for example, we know every time we create a product, it should contain a name, price, quantity, on sale, and discounts. So all we have to do to create our interface is, just like we were doing in our method parameters, let's add our properties as well as their types into the interface. So for example, we can say name is of type string, price is a number, quantity is also a number. On sale is an optional parameter, so using that question mark, of type Boolean. And discounts is an optional parameter of type string array. And what we've done at this point is we have described a product object, and we now have an interface that is telling our compiler this is what a product looks like. And once we've done this, we've essentially described an entirely new type that we can now use throughout our application. So for example, we can say cart is not an array of objects, however, it is an array of products. And you can see that immediately gets rid of our error down here, because now this product within our array loop is of type product. And of course, product has, when you say product dot, there's all of our great properties on each of our products. And that's really great IntelliSense. It becomes very, very easy to be able to tell what objects and properties are available in any particular variable. This also provides an opportunity to really simplify our add method. What we're doing in the add method by having all these parameters be separated out is we're basically type checking the product twice, because we've defined that name is a string, price is a number up here, but then we're doing that again in our method parameters down here. And that's really quite superfluous, so we don't need to do that. So let's go ahead and delete all these parameters, and instead of saying add the name, price, and quantity, we can just simply say add a product. And instead of using a destructured object here, we can simply say cart.pushProduct. And that just makes that method so much simpler at this point. But because we have an interface, we get all of that same great type checking, but we can utilize that everywhere in our application where we're interacting with products. Now this is going to cause an issue down below where we're actually using this add method, and if I scroll down you'll see that, and that's because we're now expecting one argument of type product whenever this add method is used, and however we're passing multiple arguments down here. So we're going to have to update this. I'm going to set up some multiple cursors here, and we will try to do that. And let's go ahead and make sure that each one has a name, as well as a price and a quantity. And if I scroll down, make sure these all look good. Our last one here is in a different format, so I have to clean that up just a bit. On sale is true, and discounts is equal to that. There we go. So every time we add, we're adding an object of type product. And again, you do get all of the same type checking here. So if for some reason a developer forgot to provide quantity, it's still going to provide some contextual feedback there and say, hey, wait a second, property quantity is missing. And not only that, but if I were to type on, you get some IntelliSense here saying on sale is of type Boolean, and that's optional. The same thing with discounts. You can see that's type string array, and that's also optional. So you get some IntelliSense, you get some type checking, you get all the same stuff, but we've really simplified the logic within our application now, because all of that stuff, all of those types are described in the interface, which is a nice concise way to describe this type of data. Over in the compiled version of this file, you'll notice the interface completely disappears, and that's because there are no interfaces in JavaScript. So this is only something to help developers understand the structure and the data within your objects. It has nothing to do with the runtime itself once it's compiled. So let's jump back up to the top of our file here, and we're going to add a special type that you may encounter in TypeScript called an enum. An enum is a really great type to use when you have a property or a parameter that has a predefined set of values. As an example, we could say that our product is going to have an optional parameter called type, which is going to be of type product type. And we can create that enum by typing enum product type. And what this looks like is you just type in the various values that you might have. So the product type could be a vegetable or a dessert or fruit or meat, poultry, I guess meat and poultry should not be exclusive. Poultry, fish, beef, pork, etc. And you just list out all of the options you're going to have in your enum. And now whenever you specify a type, it's going to be really easy for developers to choose which type they want to use. So as an example, if we go down to where we're adding our products, I could say apples are of type, product type dot, and then you get that nice IntelliSense, just like you see here. So I can say this is, of course, a fruit. And our oranges are a fruit. And then down here, chicken are of type product type dot poultry. Now, when I save that, you'll actually notice that an enum gets compiled down to this function. So it's actually creating a product type variable, and it's saying whenever you utilize that, it's basically casting each value to an array. And the array index is a 0-based index. And in this case, it's from 0 through 6. But you really don't have to worry about that because you're only worried over here as the developer of product type dot, and then you get that really nice IntelliSense and you just choose the option and you're ready to go. But behind the scenes, it does actually map it to an integer, as you can see here. So let's continue to add complexity here. We have our product type. Let's also say that we want to optionally provide some nutritional information in this product. And in this case, we're actually going to do an interface within an interface. As an example, we could say interface nutrition, which is going to contain calories of type number and is frozen of type Boolean. So that's our nutritional information, but now our product interface can actually contain an optional nutrition interface. And that's essentially an object within an object in JavaScript. And this is something you are going to have quite often because that's just how we do things a lot in our JavaScript applications. And this is a very easy way to nest your interfaces within one another. And now whenever we want to utilize this, we're just going to go down to our add method once again. And we could say, for example, that nutrition information on our chicken is going to have calories, I don't know, whatever you want to do there. And we also want to provide is frozen is true. And then likewise on our apples, we could provide nutritional information there. And this is in the object syntax. Is frozen is false in this case. So that's great. We're providing nutrition information. We have the type of product that we're adding to our cart. We're really starting to flesh out this application. Let's say that we want to create a method that, just like we have the total price of our cart, we want to calculate the total calories in our cart. Well, that's pretty easy to do. We can go up to our total method here where we're getting the cart total based on the price times the quantity. Let's duplicate that and we'll get the cart total calories. And we'll call this method calories, which will also return a number. But instead of adding the product.price times the product.quantity, we're going to take the product.nutrition.calories. And you do have to be careful when you're utilizing these optional parameters because nutrition may or may not exist. So it's probably a good idea to surround this in if product.nutrition. Just like that. And now this method is going to return the total number of calories in our cart, which may be very useful in this particular application. Now you may find yourself in a situation where, for example, whenever you're providing the apples, you may also want to provide some sort of additional information. So for example, the vitamin C content of this particular product. Now, obviously, we could go up to the nutrition interface and we can add an optional property called vitamin C of type number, and that's going to clear up this error that's saying, hey, wait a second, what's vitamin C? That doesn't exist on nutrition. But the reason why I'm showing you this now is because you're going to find yourself in situations where, for whatever reason, you may be working with an interface and you may get data back in an unexpected fashion. So for example, you may need to add vitamin C to something, or you may get vitamin C on a particular type of an interface, and you know that exists, but the interface isn't describing it, or perhaps you don't even know what you're going to get back. A good example of this might be when you're reaching out to a web service and you retrieve data back from that web service. It may come back in a format you didn't expect. Also, if you're utilizing an external NPM library that wasn't written in TypeScript and it has no typing, you may be interacting with that library and get data back in a way you don't expect. And for those instances, you kind of have a couple of options. You could either write an interface that encapsulates all the possible return values. And in this case, we would just go up to our interface for nutrition and add vitamin C as an optional parameter there. Or you can also use what's called a generic in TypeScript to help you work with those external libraries and services and allow you to utilize the data in a more generic fashion, where you're not specifying every possible property in the interface. And in this instance, if you want to fix this issue, if you don't want to see the error here and you want to get rid of that message and basically have your linter be quiet, one way that you can handle this is up in your interface for nutrition. You can see here we have calories and is frozen. And then whenever you utilize that interface in your product, you could say it could be nutrition or it could be anything. And any is a generic type in TypeScript. And it basically is like saying, go back to normal JavaScript. I know what I'm doing. You don't have to use a type on this particular property. Don't worry about it. I'm just going to make sure that this works. And you want to make sure that you use this sparingly because it does actually degrade your developer experience a bit. And I'm going to show you exactly what I mean by that. Now that we've marked the nutrition property of our product as either nutrition or any, which is that generic TypeScript type, now you'll notice down here, if we scroll down to where we're calculating the total calories in our cart, whenever you go to use the IntelliSense that we had before, where I would say product.nutrition, you don't get anything. And that's because product.nutrition is actually of type any. It could be nutrition, it could have calories, or it could be anything else. And as you can probably guess, this is a risky proposition in this case because accessing product.nutrition.calories could result as null because that may or may not be set because our type allows product.nutrition to be anything. So we could try to be accessing the .calories property on a Boolean or a string, which isn't going to exist, and it's going to cause an error in our application. We've gotten our linter to be quiet because you'll notice down at the bottom, now I can add whatever I want to the nutrition object. And sometimes that can feel like a win to get your linter to be quiet, but you have to be careful with this because it's going to start to have far-reaching implications when other developers are interacting with this. And if you're using a lot of generics, you're basically negating all of the benefits of TypeScript every time you use a generic. There's a couple of ways to fix this. The first thing you may reach for is a cast. And basically what that does is it allows you to take your product nutrition, which is of type any, and I could say const product nutrition equals product.nutrition as nutrition. And now whenever I use product nutrition here, I can say product nutrition dot. Sure enough, there's the properties on that interface, calories and is frozen. And I'm using a cast in this case, so I now have a variable of type nutrition, and so I get all that great IntelliSense that I had before. But this is still a potential area for bugs to occur because what we're doing is we're casting from a generic to a nutrition interface, and that generic is not guaranteed to actually be in the proper nutrition interface format, and so this could potentially be an area of concern. So even though I do see a lot of developers reach for this technique in casting to get the linter to be quiet, it's not necessarily the best way to handle this issue in this situation. So let's actually go ahead and delete that, and we'll take this back to just plain old product.nutrition.calories. And what we're going to do is up in our interface here, let's go ahead and delete this generic because we've decided that's not the right way to do this. We want to make sure that when you provide nutrition information, it is actually going to be nutrition interface. And the way we can allow for expansion of our nutrition data is to go into our nutrition interface and add a special property, and it's going to look like this. Index is of type string, and that's going to be of type any. And basically what you're doing by adding this line here is you're saying every time you have nutrition data, it's going to have calories and it's going to have is frozen, and it may have many other things as well. And each of those other things are going to be properties where the index is a string. So just like calories and is frozen are strings here, they're going to have properties that are strings, and they're going to be of type any. And this is actually a much better way to do this because you're preserving all of the great interface data and the properties that you have on nutrition, but you're allowing for expansion. You're saying there could be other things that come back from this web service or whatever. And this is something I use quite a bit in SharePoint Framework because there's a lot of instances where you're dealing with web services in particular in SharePoint Framework. You may make a request out to a web service and you may say, hey, go give me all the documents in this document library. And whenever that data comes back, there could be 50 different fields on each entry in that document library, and you really only care about 3 of them. And in those cases, I don't think it's a good idea to actually document in your interface all 50 possible fields so that you can have this perfect IntelliSense that gives you every possible thing that could be on there. I think it's better to document the properties that you care about, that matter to your application, and then you can utilize this syntax to allow for expansion when needed. So now that we've done this, if you scroll down here, you'll notice our little error has gone away. So it's still okay that we're providing vitamin C on this particular product, which is great. But also in here, we can say product.nutrition. And we still get our IntelliSense because product.nutrition is of type nutrition. So in this case, it's kind of the best of both worlds, which is great. Okay, our application is starting to get a bit lengthy, perhaps even a bit unwieldy. We've added a lot of complexity to this so far. We have all kinds of methods and things that are taking place within this script. And in order to clean this up a bit, we're going to be using the class syntax in TypeScript. And the class syntax is pretty nice. If we go up to the top here, we can simply type class shopping cart. Just like that. And when we save that, you'll notice over on the right, it's actually setting in the compiled version a variable called shopping cart, which is equal to the output of this anonymous function. And as we add methods to our shopping cart, so for example, we could add a method called hello, which returns an empty string. And you'll see over here, the method is actually added as a prototype to this variable. But we're not going to be adding this silly method here. What I want to do is scroll down here and grab all of the logic for our shopping cart application. So everything down through calories here, I'm going to cut that and we're going to paste it in to our shopping cart. And let's clean this up just a little bit. So we're going to define a property on this class called cart. We're going to take out the function declarations on each of these methods. So it just looks like that. And every time we use cart dot, we're going to have to update that to use this.cart. And once we've done that and saved, you'll notice over here, here's our nice class being compiled with those prototype methods. And we are going to have to change how we utilize this down below, which now is going to have some errors because there is no method called add. So what we'll do is we'll say create new shopping cart, const cart equals new shopping cart, just like that. So we're going to make a new instance of that class. And then for each of these add methods, we're going to say cart.add. So we're going to add products to that instance of the shopping cart. And likewise, we're going to get cart.total down here at the bottom. And that's going to complete our class. Just like that, we have created a nice compartmentalized, segregated class that has to deal with all of our shopping cart logic. And it's all encapsulated inside of that class, which compiles down to a nice prototype function in the compiled JavaScript. So this is looking great, but I think we can improve this even further. In particular, this file is getting quite long, so I want to break it up a little bit and make sure we create a separation of responsibility and concerns and keep our project nice and organized. That's also really easy to do in TypeScript. As you will see here, we can just take elements of this file and export them to an external TypeScript file and use it just as we're using now with a couple of minor changes. So for example, we can take our 3 sort of data related interfaces and our enum that are at the very top of this file, and I'm going to go ahead and cut those, and that's going to reduce this file quite a bit. But we still do need those, so let's create a new file and just call it product.ts, and we'll paste these in. And now that this is an external file, we will have to take each of these elements and put export in front of them. And that's basically just saying, hey, this is going to be used in another file that's going to import the product or the nutrition or the product type. Let's also take our shopping cart class. So that whole class right there, I'm going to cut that and just leave our very simple application logic that you see here. And I'm going to create a new file called shoppingcart.ts. We'll paste this in here. And we can do an export here, or you can do export default. If there's only one thing that's being exported, that's usually a little bit simpler. Now in this file, it's saying, hey, wait a second, what's a product? I need product information. So what we can do is import product from product. And once you do that, once you start importing and exporting, just like we're going to do here, it's saying, hey, wait a second, what's shopping cart? We can say import shopping cart from shopping cart. And once we have done this, you'll notice over on the right, we are now using an ECMAScript module that is using the require keyword. And that's a somewhat important consideration because the require keyword actually won't work in the context of a web browser. You would now have to take your ECMAScript module at this point if you wanted to run it in the web browser and not just in Node.js, and actually bundle that using something like Webpack. The good news is in SharePoint Framework, we really don't have to worry about that because the whole build and deploy process has been figured out for us, and it is a part of the build and deploy scripts that come available in the SharePoint Framework templates that are set up for us. So we also need to import our product type, as you can see here. So let's add another one up here that says import product type from product. And there we go. We now have a working application that is split up into multiple files. We are using the ECMAScript modules, and our index.ts file, as you can see, is now purely focused on the logic of our application. We create a new shopping cart, we add some products to the cart, and at the bottom, we're getting the total. Very much simpler than what we had before. And that's going to do it for our TypeScript crash course. Hopefully this introduced you to a lot of the most important features you're going to utilize from TypeScript in SharePoint Framework, as well as in other products and frameworks that you may be using. In our very next lesson, we're going to put our TypeScript chops to the test by building a React application using the TypeScript language.